Hi there, my name is Jeff Anderson. I'm the Water Supply Specialist for the NRCS Snow Survey Program in Nevada. Today I'm going to take you through a presentation that I'm calling The New Normal in Nevada, an intro to the 1991 to 2020 medians and averages. Each decade, the NRCS updates its 30-year reference period used to calculate normals. The normals are used in many of our products to state current data as a percentage. This update will shift the data forward 10 years from the 1981 to 2010 period to the 1991 to 2020 period. Shifting the reference period by 10 years means dropping the 1980s and picking up the years since 2010. During the last 10 years, we've seen multi-year droughts, extreme heat, and extended fire seasons. In 2015, we experienced the lowest snow year on record based on snow survey data going all the way back to Dr. Church in the early 1900s. A few years later, we measured two of the biggest winters on record, 2017 and 2019. We have observed firsthand how extremes in our climate continue to expand on both sides of normal. Climate is changing. The forces driving that change are both human, caused, and natural. In order to get the most out of our snow survey data and forecasts, it's important to recalibrate ourselves to the new 1991 to 2020 period because the normals affect our own perception of the current conditions. Here is a summary of what types of data have new normals. We've updated medians and averages for monthly snow course and reservoir data, and monthly and seasonal streamflow volumes. An example of a seasonal streamflow volume is the April through July period that we use in forecasting. There are also new medians and averages for daily SNOTEL data, and we've added some new annual SNOTEL stats that we haven't had in the past. These include median and averages for the date of snow onset, the date of snow peak, as well as the peak snow water amount, and medians and averages for the date of meltout in the spring. A few key points to remember about the new normals. First, all sites with greater than 10 years of data will have official normals. Since 2008, we've added 17 SNOTEL sites in Nevada to fill gaps in the network. 5 of those now have enough data to have normals. 3 of those are located in the Spring Mountains near Las Vegas. Second key point. Along with the normals update, our forecast hydrologists have also updated and recalibrated their models to base forecasts off data in the same 1991 to 2020 reference period. A couple of things that haven't changed include how the data are collected at SNOTEL sites and the methodology used in forecasting streamflow. The final and most important point to remember is that the NRCS is making the median the new default for all NRCS products when it comes to percentages. This is a change from the previous normals period when we used to use median for snowpack but used averages for precipitation, streamflow forecasts, and reservoir storage. To recalibrate ourselves to the new normals, we need to investigate both the shift in years and also the shift in statistics from the two periods based on what parameter we're talking about. In 2010, when we switched from average to median for snowpack percentages, we got a lot of questions. Why are we using the median? The simplest answer is that snowpack datasets like the one on the right are non-symmetrical. That means that a few extreme years like 2017 and 2019 skew the average higher than the median. For non-symmetric data, the median is a better representation of the middle of the dataset with half the years above and half the years below. The median is less skewed than the average by extremes. Other hydroclimatic datasets, including precipitation and streamflow, also tend to be non-symmetrical. So that is why we are switching. It should also be stated that if a dataset has a normal distribution, the average and median are equal to each other. So in that case, the median also works well as the central tendency. Now let's look at how snow, precipitation, and streamflow medians have changed by shifting the period by 10 years. We'll use a median to median comparison for this. These three graphs show how the new median has changed versus the old median for these three parameters. Each bar represents a different long-term snow-tell site or stream gauge. Downward red bars indicate that the new median is lower than the median for the 81-2010 period. In general, for each parameter, there is more red than black, indicating that medians are lower. In basic terms, this means that the new normals period is generally drier than the previous one. For April 1 snowpacks, those have taken the biggest hit, with 48 out of 57 snowtells seeing a decline in that April 1st peak snow water content. For water year precipitation, the results are more mixed, with roughly 1/3 of the sites increasing while 2/3 decreased. If we look carefully at the snowtell sites, many of the increases in water year precipitation are in the Humboldt Basin, while many of the sites that decreased medians are in the Sierra. For April through July stream flow, more than half the gauges show new medians that are plus or minus 10% of the old median, so a relatively small shift. But 17 gauges saw more than a 10% decrease in medians, and some of the biggest decreases happened for the main stem of the Humboldt River, highlighted here in yellow. To understand the impact of these lower normals, let's take a look at snowpack medians from the Mount Rose Ski Area snowtell. The pattern here is fairly representative of other sites in Nevada. Notice how when the snow is peaking in early April, the old median line in blue is higher than the new median line in red by a few inches. Now let's add 2021 data to the plot and calculate the percent of April 1 median using both the old and new medians. Last April, the site had 23 inches of snow water. Using the old median produces a percentage of 63%. Using the new median, the percentage jumps to 67%. The amount of water in the snow didn't change, just the standard that we are comparing it against. This means that when we change the normal, the result is a change in the percentage. When the normal decrease, the result is a higher percentage. Now let's do the same thing, but look at basins across Nevada for that same date, April 1st, 2021. The map on the left shows basin snowpack percentages using the 81 to 2010 median, while the map on the right shows percentages based on the newer 91 to 2020 medians. Going from the old median to the new median, basin values shift up about 3 to 10%. Also note that in the Sierra Basin, the shift is enough to make the color category change on the map. If we add data to the table from a big winter like 2019, percentages change even bigger, topping out at 13%. This quick analysis shows that moving forward, you should expect snow percentages this decade to be roughly 3 to 13% higher than they would have been if we continued to use the old medians. What was an 80% of median snowpack may now be a 90% of median snowpack, thus the need to recalibrate ourselves. So far, we've looked at how the shift in years affected water supply parameters, and we've noted that in most cases, the normals have decreased, resulting in a higher percentage. Now we will look at the shift in statistics and how that affects precipitation and stream flow percentages. We'll take another look at Mount Rose snowtell to compare precipitation medians to averages. The old and new medians are shown in blue and red. The old and new averages are shown in black and gray. Notice how the difference between the old and new median is small compared to the large shift between the average and the medians. The averages are skewed much higher than the medians due to the non-symmetric data. For precipitation percentages, the impact of going from average to median is much bigger than the small shift in climate caused by the shift in time periods. If we look at the Humboldt Basin, where we saw modest increases in the precipitation during the last 10 years, that effect is outweighed by this change from average to median. The new medians are significantly lower than either the old or new average. Now let's look at the basin data for precipitation. The maps show water year precipitation percentages through April 1st, 2021, using the old average on the left and the new median on the right. Percentages in all basins increase 5 to 13%, and that results in a color category shift in the lower Humboldt and eastern Nevada polygons from yellow to green. The table at the bottom show that in an above normal year like 2019, the precipitation percentages increase up to 20% or so. In summary, moving forward, expect precipitation percentages this decade to be roughly 5 to 15 to 20% higher than they would have been if we continued using the old averages. Now we'll discuss the impact of changing statistics on streamflow normals. Nevada is a bit of an outlier compared to much of the western US when it comes to streamflow normals. The map on this slide shows the 91 to 2020 medians as a percent of the 81 to 2010 average. If the new median and the old average are equal, the percent on the map equals 100. It's plain to see that most of the dots on the map are green, indicating that the new median is within 10% of the old average. These data sets likely have a more normal distribution in the streamflow data. The percentages in the Great Basin stand out as noticeably more yellow, orange, and red. This means the new median is much less than the old average. These streamflow points have a highly non-symmetrical data set where extreme years have skewed the average much higher than the medians. The Humboldt really stands out in this regard as a series of red dots which indicate that the new median is less than half the old average. Take the Humboldt at Elko as an example. The old average was 133,000 acre-feet, while the new median is 69,000 acre-feet. When you see this kind of shift in the normal, expect to see a big impact on the streamflow percentages. This slide summarizes how April 2021 forecast percentages change when we shift from the old average to the new median. The forecasts at the top of these graphics are in the Sierras, which were mostly green and yellow dots on the map. The change in normal produces a 5 to 10% increase in the reported percentage when you shift to the new median. This change in percentage is pretty similar to what we saw for snow and precipitation. The forecasts at the bottom of the graphic are for the Humboldt and for streams in eastern Nevada, which are highly non-symmetric data sets. Here, percentages increase by 30 to almost 75%. Last year wasn't even a big year. Expect much higher percentages of median when we do get a big runoff year. Keep in mind, in no way do these higher percentages mean that there is more water forecast. The same forecast volume was used to calculate these percentages, and the only thing that was changed was going from the old average to the new median. The higher percentages aren't wrong, it's just a new way to interpret the data. Much of the southwestern United States has had a similar issue with non-symmetric data. Those areas have already been using medians for the last number of years because of the way that the averages are skewed in the non-symmetric data sets. Here in Nevada, we need to recalibrate ourselves and get used to this new way of reporting the data. In conclusion, here are a few tips on adjusting to the new normals. First, don't expect as much water from a given percentage. Second, concentrate on streamflow volumes and not on the percentage. Third, use tools that compare actual data instead of percentages. A good example would be using the interactive charts linked from the Nevada Snow Survey webpage. Finally, take the time to investigate the normals for yourself using the Nevada Normals dashboard and the technical summary about normals. The dashboard has a number of tools which allow you to compare old and new normals for basins or individual snowtell sites or specific streamflow gauges. The technical summary has a lot of useful information about normals calculation methods and how this new set of normals is different from the previous set. Thanks for taking the time to educate yourself by watching this presentation. Hopefully it's helped to recalibrate you to this shift in normals. If you have any questions, please feel free to reach out.